Assalamu alaikum wa rahmatullahi wa barakatuh. Hello everyone, welcome to session 2 on mass spectrometry, problem solving strategy for IR and MS. What is the structure of the compound has the following IR and mass spec? From the infrared, nothing above 3000. We started with peak at 2990. This group here belongs to sp3ch stretch. We find another peak at 1710 belong to C double bond O. The infrared suggests a ketone carbonyl stretch, no CH absorption above 3000, indicates aliphatic carbonyl compound. The molecular ion has an even mass at 72, indicates no odd nitrogen atom. The base peak at 43 suggests a cerium ion structure. We have carbonyl, we have CH3, so the most likely we have a cerium at 43. We have molecular ion 72. We have C double bond O from the IR 28. So the left residue is of mass 44. 44 divided by 12, 3.67, which means that you have 3 carbon plus 8 hydrogen. And we have carbon from the carbonyl, so 3 plus 1, so this compound contains 4 carbon atoms. You have CH3 on one side, so what will be the other side? The other side will be C2, H5 of M over E29. We go to the spectrum. Yes, we have peak at 29. So, cutting from this side, we have this part 43, and we get the positive charge on this one will be 29. If you go the other way around, if we cut on this side, we get 57, and if the charge will be on the R part on the metal, we'll see 15. Yes, there is 15. I think this one is very easy, right? Just to start up the lecture with an easy one. Okay. Now, what is the structure of the compound has the following IR and MS spectra? Here we have peak at 3320 and sharp. It is in the region of OH and NH, but this is very strong. It seems like it is acetylenic. Well, looking for area of the zone of C double bond, triple bond C, yes, we can see a peak at 2100. So it looks like we have this part of the molecule, CH, and here is C, and here is R. Okay, IR again, show terminal CH alkyne stretching at 3320 and a carbon triple bond carbon stretching at 2100. Okay, we go to mass spec. The molecular ion has an even mass. Well, we don't have odd nitrogen atom. And the elimination of hydrogen radical as expected for terminal acetylenic group. Okay, so we have 67. From the molecular ion, we have minus 15 peak at 53, which means that you have M minus CH3. All right, now we have molecular ion at 68. We have this part of 25 mass. The rest R will be of mass of 43. To get the number of carbon or idea about the formula, divide 43 by 12, it will give you 3.88, which means that you have 3 carbon. 3 carbons give you a total of 36. To get to the 43, then you have 7 hydrogen, which means that you have C3 H7 group. This part, okay, and your compound may be bentine. Remember, we have 86 molecular ion, we have base peak at 67, we have a strong peak at 53, we have another peak at 40, we have a strong one here at 39. Let's see if with this structure we can نطلع بشكل واضح لميكانيكية ان من الشكل ده يطلع الايونات دي. well لو انا عملت elimination ل CH3 هيديني هنا راديكال، وهنا لو في بلس راديكال مكان التريبل بوند دي، راديكال هنا وراديكال هنا هيتحدوا مع بعض ويديني C4H5 cation, right, at 53. Elimination of hydrogen, peak at 67. If we look for the triple bond, radical in here, positive in here, and elimination of C2H5, radical with radical will form double bond and give the peak at 39. If we get this electron with this hydrogen, followed by elimination of the electron, moving of this electron, and then moving of this electron, you get the H transfer, and the same as this one, but with one more hydrogen, and that goes big at 40. So we were able to get 40, 39, 57, and 53. Okay? So the structure might be correct. What is the structure of a compound has the following IR and mass spec? In this molecule, you have peak above 3000 and a peak below 3000, which means that you have an aliphatic part and aliphatic part, alkane and alkene part. Okay, the molecular ion is showing at 120, is showing another peak at m plus 2 in almost the same height. We have mentioned before the isotope effect. M plus 2 in 1-to-1 indication of the presence of one atom of bromine. So we have bromine, and then getting from 120 to 41, there is no isotope in here, means the elimination of PR. Elimination of PR, radical 120 minus 79 give 41. So most likely what we have here is 120 minus 79, the remaining is 41, which contain the aliphatic and olefinic part. 41 divided by 12 give you 3.4, so you have 3 carbon. 3 carbon is 36, 5 makes it 41. So you have C3H5. That makes it CH2, CH, CH2, Br. And again, this compound may be bromopropene. One will say, why you are not sure? The other probability that you could have Br in here. Okay? What if the structure of compound has the following IR and mass spec? Well, here is OH. Since it's highly broad, I can't see what's underneath it. Here I have an overtone of aromatic. So this compound might be a phenol or substituted phenol. Molecular ion at 128, and again in this spectra is showing 130, it's M plus 2. It's 3-to-1 ratio. Means the presence of 1 Cl. If you eliminate from the molecular ion 28, it gives you 100 and 102, again in 3-to-1 ratio, which means that, of course, it's CO. So you did not eliminate the chlorine. So the chlorine presence in this fragment, that's why it's causing 3 and M plus 2, 3-to-1. Okay. Now, if 100 fragment eliminate Cl, now you have 65 without isotope, because the chlorine is gone. There is no isotope on this fragment. The molecular ion has M+2 in 3:1 ratio, indicates 1 Cl. 128 minus 35 minus OH17 leave a residue of 76. 76 means that you have 6 carbon, 4 hydrogen, di-substituted benzene ring. Alright? The IR and mass of a compound are shown below. Use everything you know about IR and mass spec, plus reasoning and intuition to determine a likely structure. Then show how your proposed structure is consistent with these spectra. If you examine the IR in the region of OH-NH, we can see signal peak here أحادية مش ثنائية. لو كانت ثنائية كنا قلنا دي تبقى برايمري أمين، أما دي واحدة بس، فمعنى كده لو هي احتمال هتكون سكندري أمين. نيجي عند 3000، أكتر من ال 3000 في أيوة، يبقى معنى كده إن أنا عندي sp2ch stretch، وعندي أقل من ال 3000، معنى كده إن أنا عندي برضو aliphatic sp3 carbon H stretch. The infrared suggests a secondary amine function. NH showed a single band at 3403. Absorption above and below 3000 indicates the aromatic and aliphatic part in this amine. طبعا احنا عارفين لو هي امين يعني فيها نيتروجين، لو هو اود نمبر يبقى الايه الموليكولار ايون بيك هيكون اود، بوب 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 121 odd. Okay, and we have a peak at 77. That's C6H5. That's a phenyl. So we have phenyl part and we have aliphatic part. The molecular ion at 21 odd, you have odd number of nitrogen. The presence of peak at 120, there is a peak here at 120, means M minus H. Confirm the secondary amine proposed structure. Peak and 77 belong to C6H5, indicate that this amine may contain a phenyl group. The peak at 106, the base peak, M minus 15, shows the presence of methyl group. Accordingly هيبقى عندي 121 اطرح منهم 15 اللي هم بتوع ال NH جروب، وال 77 بتاعت الفينيل جروب، وكمان ال 15 بتاعت الميثيل، يبقى الريسيديو في 14. 14 دي indication of CHA2. يبقى عندي ادي البنزين بارت، ادي ال NH، ادي ال CH3، وادي ال CH2. اشوف الاقي ان فعلا البيكة دي تتكسر وتديني 106، او المجموعة دي كلها بتطلع وتديني ايه؟ بلس at 77. برضو ده مثال an easy one. Why not? A student who was checking into his lab desk found an unlabeled sample from a previous student. He was asked to identify the sample. He did an IR spectrum and declared, "It looks like an alkane, but it seemed too reactive to be an alkane." So he did a GC mass. The mass spectrum is shown below. Identify the compound as far as you can and state what part of your identification is uncertain. Propose fragments corresponding to the numbered peak. Looking for the IR, peak are below 3000 mean that you have sp3ch stretch. It's aliphatic. For the mass spec, you see molecular ion at 198, and then you see peak at 155, 127, 71, and 43. Recall from the previous lecture, we mentioned that appearance of 127, most likely to be iodine cation. 127 with 71, you take these together, these two pieces together, they form 198. 155 with 43, another two pieces for 198. So it's most likely to be that you have an RI, alkyl iodide. From the mass spec 198, and the presence of fragment at 71, which is complement with 127 to form 198, 71 most likely to be C5H11. If you don't remember, so you take 71 divided by 12, it gives you 5.92. Take this number 5 carbon, makes mass of 60. The rest will be 71. Take away 60 will be 11 carbon. So it is C5H11. The peak at 43 is belong to propyl group C3H7, which most likely again to be a part of the pentyl part. It's RI, but looking for the 43 as a base peak, most likely, and this means that it is a stable ion, and to be a stable ion secondary, that's why we have it in iso here, a secondary will be more stable than if you draw it this way. 1, 2, 3, 4, 5 iodide. Okay? To take the propyl from here, this will form primary carbocation. Of course, you're expecting this to have rearranged in the gas phase. Well, that's why we say most likely we propose to be the 1-iodo-2-methyl-butane. Getting to this one, okay, this is a carbocation radical molecular ion. Elimination of this part give I plus, and of course this will be the radical. If the other way around, you get minus I radical, this part will be the positive charged 71. If you cleave this, forming iodonium ion, it will show up at 155. If this part will take the positive charge, that led to the formation of 43. An unknown compound gives rise to the following infrared and mass spectra. Propose a structure for the compound. Explain by citing features from both spectra. تعالوا بالراحة. ادي الاي ار. It seems that I have a broad band in here, right? Belong to OH. Sharp one, but underneath the broad at 3300. It might be terminal alkyne. To confirm that, we go to the area of carbon, triple bond carbon. Yes, there is 2100 belong to carbon, triple bond carbon. And we see in the area of sp3 carbon, we see benzene here. So you have absolutely OH functionality, you have terminal acetylenic, and you have R alkyl group somewhere in the molecule. Okay? The mass spectrum is characteristic by weak ion at 70 for molecular ion, but highly characteristic by elimination of H. Yeah, when أثناء الدراسة بتاعت الفراجمنتيشن بتاعت الألكاين قلنا لو كان تيرمينال ألكاين ممكن يفقد اتش. سو ده كمان بيأكد لي. وبعدين عندي بيك at 40 and the peak at 40 is base peak, and we have another intense peak at 31. Base peak at 40 and peak of 31 indicate that we have a primary alcohol, because go back to the 31 M minus 31, we said OCH3 or CH2OH plus, that's from primary alcohol. So we have molecular ion at 70. We can take this part out of it, which is a fragment of the terminal acetylene or terminal alkyne, minus 31, it's the fragment CH2OH, leaving a residue of 14. So you have CH2OH, this part, you have C triple bond CH, this part, and you end up with the CH2 group. Most likely your compound is 3-butyne 1-ol. 3-butyne 1-ol. Let's check the mass spec. Here is a proposed structure with molecular ion at 70, elimination of H will lead to the 69, elimination of this part will give ion at 31, hydrogen transfer as a first step, then homolytic fission to form peak at 40, okay, and we eliminate CH2O, and the H will be transferred to this carbon. Okay, now if we eliminate CH2, OH, the whole body, this part, will end with peak at 39. So we got them all. I hope that you have enjoyed the lecture, and see you in the next one.